Okay, let us start with the new subject for 7th semester. The first video for the 7th semester, that is deep learning subject. I'm gonna explain the whole module over here along with the textbook. So you can see I've opened the textbook over here. There are many things which are actually filtered in my notes, but there are few terms which I had to include my notes, but I did not. But those things are there in the textbook. So I'll be explaining from my notes, which obviously I'll provide in my what to say channel, not channel, playlist description, and you can easily fetch the notes from there. Also, the textbook. This is the textbook one. I accidentally named as TB2. I'll edit it and then share it to you. So we will move with the first topic. So this time I'll be making videos for each topic like one by one. So I've marked in the syllabus copy how many pages is this topic in the textbook. It's 5 page, 4, 5, 4, 4, 4, and then 1, 3. So you can understand by this that which page requires how much length of study studying. So for this you just need hardly 10 to 15 minutes to spend on this. I'm wasting a lot of time, already took 1 minute of you. So we'll straightly move ahead with the first topic, that is, what is the first topic, that is neural network. What is neural network? So here see you have two definitions which I have given here. First, it explains what is a neural network. It is nothing but a massively parallel distributed processor made up of simple processing units. What are these processing units? That nothing but neurons, so that has a natural propensity for storing experiential knowledge and making it available for the use. Okay, so this is the neural network definition. So you have to mention this massively parallel distributed at any cost, because that's the main key point in your definition. In simple explanation, a computer system inspired with a human brain that learns from example through interconnected neurons working in parallel. So always the neurons work in parallel, in the sense one neuron is working on some other thing, the other neuron is working on some other thing. For example, you might be speaking something else, or you might be attending the class. Your eyes will be observing the board, but your brain will be thinking about something or someone. So that's how it's parallel. Okay, so in the definition it basic. So now I can close my eyes and tell you, Aram says that it is a massively parallel distributed processor. It is made up of multiple interconnected processing units. So you have to say simple but interconnected. They are all interconnected processing units. Okay, this natural propensity, if you can remember it, else it can store experiential knowledge with and make it available for the future use. You can just say like that. Also, you can include the simple definition explanation saying that it is inspired with the computer human brain. This it is a computer system which is inspired with the human brain, and it learns from examples through interconnected neurons working parallel. Learning from experience. So if you learn something through experience, it's called plasticity in this concept. Remember, whatever you learn through experience is called plasticity. We'll see that in further topics, not topics in the same topic. We'll see that later on in this video. The key insights, what it says about the human brain and this artificial neural network is the brain computes differently than the digital computers, which means the brain is very complex. It is non-linear and parallel. Example, brain recognizes the fates within 100 to 200 milliseconds, milli or microseconds. Computers takes much longer. Okay, so like suddenly if you see someone, yeah, you can say this heroine, that heroine, or she's the one from that school, or he's the one my crush from school time or tuition, like that. You are in, I can have but the brain, it sees every feature of the face, like how eyes are there, how eyebrows, nose, mouth, the facial recognition pattern, and then it will match towards the description and then give the name. So here, how this topic can be asked in the VTU. So they might ask for 2 marks. What they will ask for 2 marks? Just for define it and list the 4 benefits. 5 to 6 marks, like explain brain versus computer or describe learning process. How the learning process, like how it starts collecting the knowledge, how it stores, how it processes it, how it gives the output. It's very easy, you don't have to, crack your head. So here they have told the 2 marks of 5 pages. See, actually, 0.5 page, I mean half page for a computer is different than for us. See, we can easily write 2 lines, we can write in 4 lines. We are the talented people, I know that. So here 2 marks is hardly, if I have to say, it's 5 to 6 lines instead of saying half page. um, it's almost like that. And 2 marks is for 5 to 6 lines. 5 to 6 marks are for, you have to write at least a page or 1.25 page, not necessarily half or 2 pages. It's too much, because if you write too much, the guy who corrects the paper, he might get irritated. What, this guy too much, too much. He might think you are a bookworm, not a smart guy, intelligent guy, and he won't give you much marks sometimes. It happened with me. It's just a experience. See, I'm using the concept already and sharing my knowledge with you. 8 to 10 marks, you have to write at least 2 to 3 pages. 2 pages is more than sufficient. But anyways, we'll go to the next point. Here you have the key terms. Neurons are the processing units. See, new processing units. It's neurons are itself the processing units. What are the processing units? These basic computing elements. You have synaptic weights. Synaptic weights, you can think it of like a ROM or RAM or like a box or a file. Okay, because it's just a connection strengths storing knowledge. So it just stores knowledge. Okay, so how it stores knowledge? So there are multiple ways it stores knowledge through experience from processing after computational tasks and all. But you have to mention the connecting strengths. So if you have to say wait, so let me just draw something and show it to you. So okay, let me take which color like this. Too much. Okay, so you have the connecting weights. If you know this is the axons. And this is the axon, this is the terminal. You have this thing, so many this is basically the human neuron. Here it will be like this. Okay, not straight line, it will be connected like that. Okay, so here you will be having it will take input from here, and this is it stores here. So this is the connecting weights, like all are connected na? So it's just like a chain holding on to each other, connecting weights, connection strengths, storing weight. So here how I just try to explain you in a simple way. I hope you understood. Learning algorithm is nothing but the procedure to modify the weight. So you have all these weights. So suppose there is one weight here, one weight here, one weight here, one weight here, and they all are connected. I see this connection itself already there. So how you use these weights, how you modify the value or the data in these weights and use it to process, for computing, etc. That is nothing but the algorithm. The algorithm itself takes the inputs, modifies it, learns from it, etc., etc. I told you plasticity is nothing but the ability to adapt based on the experience. It's nothing but the knowledge gained through experience. How, so suppose you were walking in a river. I mean, not completely, you're not sinking it. It's just like flood, Bangalore, some local areas. No, there will be a lot of, flood and all, and the whole road will be covered in water. So it's nothing but the same thing. So when you walk, you might not know that there is a pit or something over there or any obstacle. But once you walk and you get injury, then later, the next time when you walk, you will be, cautious or aware that, okay, there is something over here, I have to avoid that. Generalization is nothing but it's producing the meaningful and correct outputs based on the inputs. The inputs can be the new inputs or unseen inputs. It's basically just producing good output for the input. Supervised learning, it just uses the label data and provides a learning thing. It's very easy and simple. I'll try to explain in very short thing, but if I try to explain in short, you might not understand the concept. So I'm just trying to explain you, giving examples, etc. So human brain, brain inspirations. Why neural networks? Human brain features. So it's very highly complex, non-linear. It's parallel processor. It's act as a parallel processor. It is actually parallel processor. Sorry for the words collapsion accent over there. So see, it can recognize a face within 100 or 200 ms. It can be millisecond or microsecond. You just mention ms. That's more than enough. Which means it's faster than computers. It learns through experience. That is plasticity. See, it learns. If you have to give an example for a human brain, you can give bats an example. The bat it emits the waves, sound waves. The sound waves hit to the object, and when it hit to the object, it reflects back the some waves. So suppose this is Batman AI. Lol, I forgot the symbol, bro. It's like this, right? Lol, I don't know. So see, it gives echoes, big echoes. Yeah, sound waves. Suppose there was an object over here. It reflected. Now it will give back. So see, it's sending, it's receiving, it's understanding. So it's multiple. What to say? It's demonstrating the parallel processing power. And also, you will just comment whether the bat symbol is right or not. Oh yeah, when I remember, please guys subscribe, man. You guys mostly you are all my classmates, whoever is seeing the video in the present, year in 2025. But the ones who see in 2026, 2027, please, man, you guys will be juniors to me, and so subscribe. What's wrong with you? There are actually 7 to 15k unique viewers. K, man, 15,000. My channel should have crossed 10,000 subscribers long ago, but out of this, hardly 800 have done. It's very bad. Okay, plasticity is nothing but developing brain revise itself through experience. Okay, it's just developing brain. It's for humans. Okay, plasticity is a feature of human brain, and it is also implemented in the neural network. So especially first 2 years, artificial NN use the same concept adapting through learning. Two brain properties. Okay, so yeah, in this textbook you have a long thing for this, and you have see here the true brain property is nothing but over here. Knowledge is acquired by the network from its environment through a learning process. Interneuron connection strengths known as synaptic weights are used to store the acquired knowledge. In the sense what? Okay, where did I go? Okay, it's here. See, knowledge acquired through learning from the environment. That's the first point. Very simply simplified, right? Then the knowledge stored in synaptic weights. So the knowledge which you acquired from the environment is then stored in the synaptic weights, which is nothing but connection strength. That is nothing but the other property. One is learning and gaining knowledge, another one is storing. For examples, you are attending a seminar or something or a class where they don't give you notes, so you listen to them and you write your running notes, so you're gaining knowledge, and from your own way of you process that knowledge which you heard from the teacher, and you wrote in your simple terms in your notebook. It's very good example of two brain like properties which you already do naturally. That's what you are trying to implement in the artificial neural network. Learning algorithm modifies synaptic weights systematically to achieve design objectives. The way I created these notes is nothing but I saw the textbook, I took the content for the textbook, and then I modified the content. See, that's the algorithm. I use the algorithm to filter the contents from the textbook and make this very good notes. See, we are all implementing our brain naturally. It's just what we are doing without our awareness or consciousness. We just have to put it in a system or to the software and hardware. Benefits of neural, there are 9. Okay, you have to remember the heading. If you have to see N, then it has I, A. Non-linearity input output mapping. So this I is an adaptivity evidential response. You have contextual information, then you have fault tolerance, you have VLSI uniformity of analysis, and neurobiology VUN. Okay, VUN. Neurobiology uniformity VSLN. This is fault tolerance. Contextual something is there. This is evidential something is there. This is adaptivity, input output mapping, and non-linearity. See, evidential response. It's very simple. Let me just explain to you. Okay, what is non-linearity? First, you have to say, look in the textbook. A human brain can be, what to say, linear or non-linear. See, an artificial, sorry, I'm not human brain, what am I saying? An artificial neuron can be linear or non-linear. Okay, if in the network, if there is a neural network and even one, okay, neuron is interconnected with a non-linear network, then the whole thing is non-linear. Understood? See, network of non-linear neurons is non-linear. Suppose you have a neuron. Just understand this is a neuron. They all are interconnected to each other. Okay, so now if there is a non-linear neuron, if even one is interconnected with this, now, so this whole thing is non-linear. Okay, so it is essential for real-world problems such as speech signals are non-linear. Non-linear. And also remember that it's now what to say very okay. That's another topic. I'll say about that in different topic. So input output mapping. It's nothing but supervised learning. Okay, so you have to tell this one thing over here. See, it is a very popular paradigm of learning called learning with a teacher. So that is nothing but supervised learning. This is one, you got one point over here to write about input output mapping. So it learns from the labeled training examples. We know supervised learning, it is a type of machine learning. So we can just conclude over here. Modifies weight into minimize error between desired and actual output. So it's here. See, weights of C involves modification of synaptic weights of neural network by applying a set of labeled train example or task Each example consists of unique input signals and corresponding desired target response. That's what they have written here. Similar to non-parametric statistical inference, that is no prior assumptions. So here we won't be having any prior assumptions like array it can be like this, it can be like that. Directly what we get the label data will start processing and give the what to say solution or answer. Example, pattern classification without probabilistic model. Adaptivity is very simple. No matter what, you have to adapt to the environment. So there might be any sudden changes in the environment. You're walking, suddenly it's very sunny, but suddenly it starts raining. So you have to go stand in a what to say shelter and wait until the rain stops. Or if you're very cautious guy, you might carry an umbrella in advance. Anyways, it's just like that. So adapts weights to environmental changes. What is weights? It's nothing but the knowledge storage. It adapts weight to the environmental changes. Real-time adaptation for non-stationary environments. What is non-stationary? It's like not stationary is nothing but it's static, non-stationary. Okay, so one is moving, one is not moving. It's just like that. Warning is nothing but stability and plasticity dilemma. Okay, so what is stability? It's very stable under all the circumstantial condition. And what is plasticity? Learns from the experience. This both thing dilemma is what they are saying. If it is too fast, then it responds to noises too. What is noise? Unnecessary things, too many things. It has to detail and all, etc., etc. Too slow, it misses changes. Okay, many things it will miss all many changes. What is happening? If it is too slow, it might not, what to say react to the changes in the environment, like it's started raining, it won't even react to it. It's very slow. It's like that. Too fast, it might, for even a small slight wind, it will say, oh my god, it's a typhoon coming. It's just like that. Okay, what is evidential response? It's very simple. I'll explain you in very simple topics. See, the new artificial neural network will generate output with based on specific pattern. It will select a pattern to solve or process everything. Okay, so now what is evidential response? Whatever the what to say AI, if I'll take an example of AI, I asked the AI to do something and it selected a particular pattern out among several patterns. It just selected a particular pattern. So now it will show me that I have selected this pattern and I have found this answer. So this is a normal response. In evidential response, along with this pattern, it should also show the confidence in this pattern. For example, I selected this pattern because it's very good at this. It has very many features like this, and which is helpful for a particular thing. For example, Claude Sonnet is the latest model from the Cloud AI, and it's very good for academics. So you have Claude Sonnet 5 and thinking in that. So I'm giving a confidence evidential response saying this it has many things and it's very good for that is the thing. For example, if you are a vendor and they sell right, karabagala, you won't it spoil after this many days. Array, I'm giving guarantee anything will happen. You come to me, I'll take and give you back refund or exchange something. 100 years warranty. It's like that. Okay, it rejects the ambiguous patterns to improve performance. Contextual information, every neuron affected by a global network activity natural handling to context. It's very simple. Let me explain from textbook. See, built-in capability to adapt adaptability, evidential response. See, it shouldn't provide information only to particular pattern to select, but also the confidence in the decision made. Why it selected that pattern, you have to give the confidence. Contextual information. See, that's what we are saying, right? Every neuron in the network is potentially affected by the global activity of the other neurons. There are 100 people. If one people, I won't say anything, causes flu, which is airborne disease, so it will affect the other students as well, right? Within the same network. Obviously, it's just like that. Consequently, contextual information is dealt with naturally by a neural network. So all these things is naturally, dealt by the ANN, artificial neural network, or just NN. So you don't how it is by it will affect one neuron is globally affected by the other neurons, but how it will react naturally. Okay, fault tolerance is nothing but sometimes if there is a problem or some any damage or something goes wrong, no, so the whole system shouldn't fail apart like catastrophic failure. It should actually go in the graceful degradation. You can see over here, fault tolerance should be capable of robust computation. The performance degrades in the sense that is performance degrades gracefully under adverse operating conditions. This is an example after just skip that. So a neural network exhibits a graceful degradation in performance rather than catastrophic failure. See, all the words have been taken from the textbook. So you don't have to worry about the notes and whatever I'm teaching. VLSI implement. Okay, implementability. What is VLSI? Okay, the full form is here. Very large scale integrated technology. Okay, so here what you say, it is a massively parallel nature of neural networks. Okay, the massively parallel nature of neural network makes it potentially fast with the computation of certain tasks. Okay, we know what is VLSI, very large scalable integrity. Okay, so here parallel nature suits hardware implementation. It's very fast computation for complex tasks. Simple, right? You can add the in full form, so that makes 3 points. Uniformity of analysis. So here's same notation across all the domains. No matter what I get, I'll share to everyone and have it. And whatever happens, I got a knowledge, I'll share with everyone. See, bro, I got this knowledge. Even you take it, even you understand. I got a exam package for like confirm 10 questions will come in for an exam. I'll share with my friends, my group. But you have to share with everyone. Anyways, so you have modular network possible. What is modular network possible? Since it is uniform, so here see models can be built through seamless integration of models. All these 3 points have been written over here. See, share theories and algorithm across applications, same notation across all domains. That's it. Neurobiological analogy. Here there are two things. There are neurobiologists and neurobiology engineers. Biologists, they use the technology to do further research, more research and all, to find out things. But engineers, we engineers, what we do, we use the technology, the neurobiology technology, to innovate and design multiple things like new robots, artificial intelligence, it will how it will react to the inputs and how it gives better outputs. It's just like that. See, first you have to tell that it is inspired by proven biological system. Example, we are vestibulo-ocular reflex modeling, or retina inspired by neuromorphic chips. Here one thing was there which I think I did not highlight, but you can see here the design of neural network is motivated by analogy with the brain. Analogy is nothing but the inside part of the brain. Morphology is the outside appearance. Analogy is the inside or whatever. The living proof of the fault tolerance parallel computing is not only physically possible but also fast and powerful. See, neurobiologists look to artificial neural networks as research tools. Okay, see the biology people, scientists and all, they look as a research tool for interpretation of neurobiological phenomena. On the other hand, engineers look the neurobiology for new ideas, solve problems more complex than those based on conventional hardware design. Okay, these two viewpoints are illustrated with the following two respective examples. See, you have the viewer wala thing over here, the whole thing. Then here the retina thing. So if you just read this, pause it, aram sing. You can just pause and see, what's there in that. I don't have to pause and wait for you to complete. So that completes the human brain. You have just two or three main, ending tips. I'll say and complete that thing. Actually, it took a lot of time, but from now I won't take so much time. Neurobiological energy. Okay, computing sources. Massively parallel distributed structure, ability to learn and generalization, producing reasonable outputs for inputs not in training sets. See, producing reasonable outputs. Practical note. NN work best integrated into system engineering approach. Decompose complex problems into simple tasks, matching NN capabilities. Quick definition. They are massively parallel, structure which have some simple units. What is that? Simple processing units which are nothing but neurons, and they have plasticity, nothing but learn from the experience. What is brain? Complex nonlinear parallel, how it recognizes the face, bad sonar example. Two properties: when it learns from the environment, then whatever the knowledge is gained, it will store in the weights. What is nothing but what is that? um, what is that, bro? That connecting strength. Yeah, connection strength. Benefits, there are 9. See, NIAECFVUB. Example, face signal, bad sonar, spam filters. Key terms: neuron, processing unit, synaptic weights, and the connectional strength, plasticity, learning from experience, generalization, producing meaningful outputs. And here there are some answers to some questions. Define neural network. List the benefits of neural network. Explain how NN differs from conventional computers. You have all the answers. See, this thing is supposed to be 1 or 1.5 page according to the AI, but actually it's not, right. Explain neural network benefit, 10 marks. You have to talk about brain versus computer, neural network definition, two brain-like property, how it acquires knowledge and how it stores, learning algorithm concepts, how it modifies the weights. Explain any 5 features. You had 9, right? In that you explain any 5. Explain any one real-world example. Finish. Conclusion. This is the tip for you for your exams. We'll see in the next video with the next topic.